Welcome to You Got Hope Chemistry. I'm Hope, and you're about to learn some chemistry. In today's lesson, we're going to learn about solution stoichiometry. So previously, we've learned mass stoichiometry. And in mass stoichiometry, everything was based around mole ratios, which are simply a fraction between two substances in a chemical reaction. Let's say we had A plus B and their coefficients were 2 and 1. It is a ratio between those coefficients. So for instance, 2 moles of A for every 1 mole of B. So we used mole ratios, which we will still be using today, in combination with this equation, moles is equal to mass over molar mass, or the variation of mass is equal to moles times molar mass. Now, the way I always prefer to do it is not to use equations, but to actually use fractions, which is called unit analysis, where we cancel out units on the top of one fraction with the units on the bottom. So for instance, instead of using moles is equal to mass times molar mass, this equation here, if I had the mass and the molar mass, I could simply do it as a fraction, canceling out grams. So for instance, if I want the unit of the mole to be my answer, I want the mole to be on top of a fraction. So I'm just going to throw out the idea of oxygen, O2 gas. Let's say we had 5 grams of it, okay? If I know the molar mass, which is 32 grams for every 1 mole, now we normally write it as 32 grams per mole, I can invert this to get moles on top. It doesn't have to be written as there are 32 grams in 1 mole. It could also be written as for every 1 mole of oxygen, I have 32 grams of oxygen. And then simply, I have to get rid of this unit of the gram. So I'd say, all right, well, I got 5 grams. I just made up that number. I've got 5 grams of oxygen. How many moles is that? That cancels out the grams. And I'm left with the unit of the mole, because a mole times nothing is a mole. And then I simply have to calculate the value. So it would be everything on top of the fractions divided by everything on the bottom of the fractions, and I get an answer. So this would simply be 1 times 5, which is 5, divided by 32, which is 0.156 moles. Or I could have used moles is equal to mass over molar mass, plugged in the numbers, and I get the same answer. The thing is, if you proceed on in chemistry and you go to university, your professors aren't really going to be using equations like this. They're going to be doing everything in unit analysis. And when you do stoichiometry, everything will be in unit analysis. So this is a one-step question. Most stoichiometry questions are a 3-step question. So I'm going to teach this using equations like C is equal to N over V and mass is equal to moles is equal to mass over molar mass. I'm going to do it both ways, and you can choose which way you want. However, I do really want to push the use of unit analysis if you are planning to take chemistry at the university level. Okay, so if you're now wondering, well, Hope, you just reviewed mass stoich. What's solution stoich about? Solution stoich, we do the exact same stuff, but instead of using moles as mass over molar mass or mass as moles times molar mass, we use C is equal to N over V, or N is equal to C times V, or we use V is equal to N over C. Same idea. We're always trying to get moles to do a mole-to-mole ratio, and it always requires a series of steps. So we're going to do 2 types of questions. One where we are forming a precipitate, and we're trying to figure out the mass of the precipitate. That's going to be question number 1. And then question number 2, we're going to look at, we're still making a precipitate, But what we're going to look at is the reaction between the reactants and figuring out the volumes of solutions we need to mix together to selectively precipitate out an ion, which ties into the selective precipitation part of this unit. Okay, so the first thing we're going to do, we're going to read the question, then I'm going to get you to pause the video, and I want you to write out the balanced reaction for this reaction. We are going to keep it as a double replacement for stoichiometry. We could always convert it to a net ionic, but I want us to keep this as simplified as possible at this point. So it says, calculate the mass of precipitate produced if 10 milliliters of 0.5 molar silver nitrate solution is reacted with an excess calcium chloride solution. So step number 1 is going to be for you to write the balanced double replacement reaction between calcium chloride and silver nitrate solution. Pause the video now and write out the balanced chemical reaction. Okay, now that you've had a chance to do that, let's work on it. Silver ion is Ag plus and nitrate ion is NO3 minus. Calcium ion is Ca2 plus and chloride ion is Cl minus. So I've got to make sure I balance my charges when I do my balancing. So I have 1 silver with 1 nitrate because it's a 1-to-1 ratio in terms of charge. It's aqueous because it's a solution. Plus, well, I'm going to need 2 chlorides to balance out the 2 positive charge. So CaCl2 aqueous. And that is going to turn into, well, if it's double replacement, the calcium is going to swap with the silver. So I'm going to end up with silver chloride. Now I'm going to check the solubility of that in my data book. Silver is very insoluble with a lot of things, and it turns out that it is solid. This is my precipitate. Then calcium is with nitrate. Nitrate is soluble with absolutely everything, so this would be Ca bracket NO3 bracket 2, and this is going to be aqueous. All right, now we need to balance the reaction. I have 2 nitrates on the right. I need to make this 2 here. That means I have to make the silver chloride 2 here. And then the calcium's a 1 and the calcium nitrate's a 1. Okay, so that's our first step. We balance out the double replacement reaction. If this isn't done right, then your mole to mole ratio is going to come out wrong. So it is vitally important that you can write and balance chemical reactions perfectly. All right, our next step here is to write out all the information we have and don't have so we can start figuring out what we're going to do. So I'm going to start by, step number 2 is going to be writing everything out. I have 10 milliliters of 0.5 molar silver nitrate. Okay, so the concentration of silver nitrate is 0.50 moles per liter. The volume is 10 milliliters. Now, because this is in liters, we should convert it to liters. It's 0.0, that would be the 100 milliliters there, and 100. So that would be 10 milliliters converted into liters. Now, in any stoichiometric process, we always have to calculate moles. It's the baseline of all the work we do. So I am going to have to figure out the number of moles of silver nitrate so I can do a mole to mole ratio. Now the other piece of information I have is really a non-piece of information. It's saying that we want to figure out the mass of the precipitate, which is this solid, so I don't know that. So my first step would be to convert the concentration and volume into moles. The reason why is in order to compare 2 compounds or even elements in a chemical reaction, we can only compare them by their numbers of moles. That would allow us to do a mole to mole ratio from one substance to another, which was the fraction I showed just up here. So our second step would be to do a mole ratio so that I could get the number of moles of the precipitate. Now the question didn't ask for how many moles of precipitate I have, it asked for how many grams. So in order to turn the moles into mass, I would need to know the molar mass of silver chloride. Okay, so go to your data book now and calculate the mass of silver chloride. Okay, so I got 143.32 grams per mole. So if I had moles and I had the molar mass, I could use those two things to calculate my mass of precipitate. So I'm going to use fractions and equations simultaneously. So what that would look like in step 3 would be moles is equal to mass times molar mass. And what that would look like for step 1 would be moles is equal to C times V. Okay, so I'm going to solve this question two separate ways simultaneously so you can see what unit analysis really is. It's a simpler way of doing equations where you don't have to memorize equations and that it's very flexible in how you use it. All right, so I'm going to start with unit analysis on top. In my first step, I must end up with the unit of the mole for silver nitrate as my answer, which means I need the mole of silver nitrate on top of my fraction. The rule is when I'm trying to figure out which one of these two numbers I'm going to start with, I always like to start with the number that has a single unit because it will always work out. So for instance, in here, I have liters and moles per liter. Well, liters is a single unit and moles per liter has 2 units. So I would start with liters. On the other side, if that was the case, mass is grams and molar mass is grams per mole, I would start with grams if I had mass because it's a single unit. So let's start with 0.0100 liters times. Now what I would like is moles of AgNO3, so I have to put that on the top of my fraction. That's what I'm solving for. And what I'd like to get rid of is the liters, so I'm going to put liters on the bottom. Well, what has moles and liters in it? Concentration. That is a fraction. This is 0.50 moles of silver nitrate in every 1 liter. That's the exact same thing. So as a fraction, that's what that calculation looks like. This is step number 1. As an equation, I would simply write moles is equal to C times V. I plug in the concentration, 0.50 moles per liter times 0.0100 liters. Okay, so both of these are exactly the same thing. This is exactly the same as that. Now the difference is, if I was continuing on with this, I wouldn't calculate anything at this point because I'm just going to do it as one big calculation in the end. Whereas down here, I'm going to have to put this in my calculator and actually get an answer. So 0.5 times 0.01 should move the decimal over. And so this is 0.005 moles of silver nitrate. That is also step number 1. Okay, now what's happened is the liters have canceled out with the liters and left us with the unit of the mole, and same thing here. The liters has canceled out with the liters, which has left us with the unit of the mole. Our next step is to do a mole to mole ratio. Now there is no equation for this. This is just a fraction. It's a ratio. A ratio is a fraction. Now, whatever I'm solving for has to go on top. So for instance, I'm solving for the number of moles of silver chloride. I'm putting that on top. Moles of silver chloride. Whatever I'm trying to get rid of, which is my moles of silver nitrate, has to go on the bottom. Moles of silver nitrate. Now I recognize that when I'm using unit analysis because I have the moles of silver nitrate as my answer. Whatever's on top cancels out with whatever's on the bottom. It has to go to the bottom. Now the numbers that go in these two spots are the coefficients. So I have 2 moles of silver nitrate, that's 2. And I have 2 moles of silver chloride, that's 2. So these actually cancel out, but they most definitely aren't always the same number. It could be 3 and 2, 5 and 8. It could be all types of different things. So this is step number 2. That would look the same way down here. There's no difference. I have to set up a fraction, and this would be 2 moles of silver nitrate. And on top would be what I want, which is 2 moles of silver chloride. And what would happen is the moles here cancels out with the moles there. Same thing here. The moles of silver nitrate cancel out with the moles of silver nitrate, and I'm left with the moles of silver chloride. Now, up top, I'm not going to punch this in my calculator. I'm going to do it all in one go. Down here, I have to. Now, 2 over 2 is 1 over 1. So I'm going to end up with the same value, 0.005 moles of silver chloride. Now, if you're going, well, if the ratio is the same, do I have to show the step? Absolutely. Because calculations aren't always number-based, they're also unit-based. And I'm converting the units over. I'm converting from moles of one substance to moles of another. This must take place. Okay, in our last step, I want to convert these moles of silver chloride into mass of silver chloride. So I know whatever I want to get rid of must go on the bottom of the next fraction. I want to get rid of moles of silver chloride. And whatever I want goes on top. I want mass. Well, mass is in grams of silver chloride. Now, what has grams and moles in it? Molar mass. What did we calculate? Molar mass. So for every 1 mole of silver chloride, there's 143.32 grams of silver chloride. This would be step number 3. And what would happen is the moles on top cancels on the moles on the bottom. And now I'm left with the unit I want, which is grams of silver chloride. How I would put this in my calculator is I take everything in the numerator, open bracket, type the whole thing in, close bracket, hit divide, open bracket, denominator, multiply everything through, close bracket, equals. So after punching that in my calculator, I got 0.716 grams, but I need 2 significant digits, so 0.72 grams. Now, how I would finish it off down here would be using this equation, m is equal to n times m. So I'd carry my answer down, 0.005 moles. I would multiply that by the molar mass, 143.32 grams per mole. The moles would cancel. So punching that in my calculator, I get the exact same answer of 0.72 grams. So whether you want to do it in unit analysis, which is using fractions, or whether you want to do it as 3 separate steps where you calculate at the end of each step, is completely up to you. It's whatever works best for you. However, I do again push, if you're going to take sciences, or you're going to take engineering, you will have to take Chemistry 101, 102, or Chem Eng. Your professor will be using this method up here. Please try to do it in the unit analysis method. So in our next question, we're going to have a slight variation on the previous question. But what I'd like you to do first is write out the balanced chemical reaction for the following statement. What is the what volume of 0.30 moles per liter aqueous magnesium chloride do you need to add to 70 milliliters of 0.4 moles per liter aqueous silver nitrate in order to remove all of the chloride ions? So essentially, how do we remove all of the ions when we make a precipitate, when we precipitate something out? Pause the video now and write out the double replacement reaction. Now that you've had a chance to do that, I'm going to go through it. So first of all, magnesium chloride is made up of Mg2 plus and Cl minus. Silver nitrate is made up of Ag plus and NO3 minus. So balancing this off would be MgCl2 aqueous plus AgNO3 aqueous, and this would turn into AgCl because we're going to cross them, so AgCl, this is a solid, plus magnesium nitrate, nitrate soluble with everything, so this is aqueous. Now the question isn't asking us what is the mass of the precipitate, it's asking us how much of each solution do we have to mix together in order to get all of the precipitate to come out. That's what it means. Now we need to balance this first. I need 2 chlorides, now I need 2 silvers, and we have nitrates balanced, so this is what it would look like. The next thing we're going to do here is we're going to take all of our information from the statement and put it underneath the compounds that it applies to. So the magnesium chloride has a concentration of 0.30 moles per liter. And the question is, what volume of it do I need? Okay. Now, in order to do this, I would have to have the moles. So I'm going to have to figure out how I'm going to get the moles of magnesium chloride. On the other end here, I have a concentration of silver nitrate of 0.40 moles per liter, and I have a volume of it of 70 milliliters. So 0.070 liters is the same as 70 milliliters. And of course, in all stoichiometry, we're always working towards getting moles. So now that I have it written out like this, I understand what my first step has to be. I only have one of 3 variables here. How can I solve for anything underneath magnesium chloride? Whereas with silver nitrate, I have 2 of 3 variables. So I understand what I need to do. I'm going to start over here and use these variables, or values I should probably say, in order to calculate the number of moles. Now as an equation, that would be moles is equal to C times V, just like our first question. Now once I have the number of moles, I can do a mole to mole ratio because I have coefficients. So it's a 2-to-1 ratio. I can use those coefficients to convert into moles of magnesium chloride. Well, that would mean I would now have 2 of the 3 variables in order to calculate volume. So then I would use those in a third step to calculate the volume. Now, if I'm using the concentration equation, volume will be calculated by going moles over concentration. So let's begin the process, and I'm going to do it again simultaneously, doing both unit analysis as well as using an equation. So starting over here, what unit am I going to start with? I'm going to start with liters because I always want to start with the unit that has a single unit when I do unit analysis. So 0.070 liters times, for every 1 liter there is 0.40 moles of AgNO3. Now this is step number 1. It's the same as saying N is equal to C times V, which is going to be 0.40 moles per liter times 0.070 liters. So 0.4 times 0.07 is 0.028 moles of AgNO3. So I got my answer for that step. Of course, in unit analysis, I wouldn't put it in there. I'm going to put it up here for now. So 0.028 moles. Okay. So what's happened is the liters has canceled out with the liters has canceled out with the liters. Our next step is our mole to mole ratio. Now, whatever is on top of my fraction here, AgNO3 has to go on the bottom of my next fraction. So this would be moles of AgNO3. And whatever I'm solving for goes on top. So that would be moles of MgCl2. So there is 1 mole of MgCl2 for every 2 moles of AgNO3. I'm getting that from the coefficients. So I'm going to multiply that by here. I have 2 moles of AgNO3 for every 1 mole of MgCl2. Okay, so the units would cancel. Moles cancel out with moles. I'm left with moles. This is step 2. Okay, this is step number 2. And let me get an answer. So that's going to be 0.014 moles of MgCl2. Okay, our third step, we need to convert those moles into liters. So whatever I want goes on top, which is liters, and whatever I want to get rid of is on the bottom, which is moles. So moles of MgCl2. Well, what has moles and liters in it? Concentration. Okay. Now, if you're going, oh, that's weird, it's moles per liter, isn't it? Why does he have liters over moles? All I'm doing is inverting that fraction, taking it to the power of -1. I'm flipping it. Okay, so all it means is I have 1 liter. For every 1 liter, I have 0.30 moles. This would be the third step. Now, what would happen is the unit of mole would cancel out with mole. I'm left with liters, which is what I want. To put it in my calculator, I would just take everything on top, hit divide, everything on the bottom, hit equals. A value of 0.047 liters or 47 milliliters. Now how that would look like the other way is I would take my value with me and I would do this. Volume is equal to moles over concentration. So the moles is 0.014 moles all over the concentration of 0.30 moles per liter. The moles would cancel out. 1 over 1 over a liter would invert the unit, and so I get the exact same answer of 0.047 liters. Whichever way works best for you is fine by me, as long as you're getting it right. I hope you have enjoyed this lesson of You Got Hope Chemistry. See you next time.